Homework time. Here we are for homework time. Happy homework time again. So let's start things right for lesson 3 here. Jot our name down at the top of the page. I'll put my name. You put yours. Whatever alias you go by. And let's take a moment and do things right. Jot down today's date. I will write today, you write the actual date, where and when you are. And you'll be glad to hear tonight's homework is so straightforward. We're ending this first little topic here, and so we just have 4 word problems to do, 4 word problems. Let's dive right in. I love this stuff. Solve the following problems. Oh yes, we will. Use pictures, numbers, or words to show your work, okay? Now we do need to write a statement as well, okay? So let's jump in with Katie. She's got some things to wrap. So Katie here, she cut out a rectangular piece of wrapping paper. So we have a rectangle that was 2 times as long and 3 times as wide as the box she was wrapping. Well, that makes sense, right? You got to cut the paper bigger than the box. You want to go all the way around. The box was 5 inches long and 4 inches wide. What is the perimeter of the wrapping paper that Katie cut? Okay, good. This is a nice little puzzle for us to solve. So let's start off by drawing the box. Let's just do a simple drawing, very simple drawing. So we know it is 5 inches. I'm making this nice and small here, right? Long and 4 inches wide. I'm just doing that for reference so I can see it. It's 5 inches long and 4 inches wide. So now it is 2 times as long. So 2 times is 5 here. Okay, so we can do that, right? So it's going to be 5 and 5. All right. And then 3 times as wide. So it's going to be 4 and 4 and 4. Okay, hey, we did that. In fact, let's go ahead and we know that we have it 2 times as long. Make a little diddly-doddly line there. Oh, that's beautiful. So I know that this is 5 inches and this is 5 together. How long is the paper compared to the box? How long is it here? It is 10 inches, right? That makes sense? 2 times as long, 2 times 5, right? And then it is 3 times as wide, so make some diddly-doddly doos going down there. Doop, 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 doop. See? 1, 2, 3. And so that's 4 inches to make it 3 times as long. 4 inches and 4 inches. How wide is the whole thing then? 3 times 4, right, is 12. And you notice I'm going with a lot of assumptions that you know how to multiply, you know how to do this stuff. I can't be teaching you subtraction all year, right? Or whatever. All right, so let's look at this now. Our question is, what is the perimeter of the wrapping paper? So here's the wrapping paper, and we want the perimeter. Now we know how to find perimeter. We know that if we double the length and the width together, that we will have the perimeter, which is the distance all the way around, securing the perimeter, walking around the outside of it, that line. So in this case, our perimeter will be 2 times, well, what's our length and width? It's 10 and 12, right, on the wrapping paper. So 10 plus 12. I'm going to pause for just a moment and show this is why I write out the formula. Because otherwise you might make, if you just jump right into doing too much in your head too quickly, you might multiply these numbers instead of adding them, or who knows what. So write out that formula until you are just like so solid that you never make a mistake again and you get promoted to whatever. Okay, so then our perimeter will be 2 times, well, what is 10 plus 12, but yes, 22. And I am going to assume that you can do 2 times 22. That's right, 44. And now this is one thing where you do want to be a little cautious. Make sure you use the right units. We're talking about the perimeter. We're talking about walking the line, secure the perimeter, walking around that paper. So we're just dealing with straight inches. We're not looking at the area. Can you believe we're already done with number 1? And there's only 4 questions. Hooah! Let's do it. All right, well, here in number 2, we have Alexis, and she also has some paper, but she's not wrapping presents. Not for you, neither for me. Alexis has a rectangular piece of red paper that is 4 centimeters wide. Its length is twice its width. Okay, now we're going on to something else. She glues a rectangular piece of blue paper on top of the red piece, and this blue paper now measuring 3 centimeters by 7 centimeters. So the question is, how many square centimeters of red paper will be visible on top? Wow, this is an interesting little puzzle, isn't it? So let's just start by getting our heads around it. Let's draw Alexis's lovely little papers here. So it's 4 centimeters wide. Okay, so that's 4 centimeters is our width. And now the length is twice that. So it's going to be bloomba and bloomba. Okay, and we'll make it an actual rectangle. And I want to show that I doubled it here. That's 4 centimeters. And 4 centimeters. So what is the length while we're here? Let's just take care of that. Yeah, that's right. 8 centimeters, no problem. Okay, so this is the red paper, and I'm just going to make a little notation here that we're talking about the red paper there. Now the blue paper we see is, let's draw blue. Now these aren't going to be perfectly proportional, but I kind of want to get them so they look somewhat the way they should in relation to each other. It's 3 centimeters by 7. See, so this one's 4, that line's 4. So my 3 centimeter line is going to be a little shorter. All right, is that good? I hope so. That's what you get. And then my 7 is going to be a little shorter than the 8. So I just want to make sure I'm, just for my own head's sake, that I'm keeping it straight, that this one is smaller. And because it's relevant to the question, it's 3 centimeters by 7 centimeters. So obviously when I put this on top of that, and it doesn't say how she puts it on top of it, we're going to go with certain assumptions that she doesn't like put it at an angle or off at the side, but that she actually places it on top. It could be either centered or aligned to a corner for the purposes of this question, although again, they don't actually specify. So, but let's just see what this would look like. Let's just make a little doodly-doo here to kind of think about this. So here's red, right? And then blue. Oh, that's horrible. Okay, and then we put blue on top, right? It's a little smaller, right? So I'm just going to shade in. So here's blue. Zigga, 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 zigga. I could have switched colors, but anyway. And so we see we're going to have, in the way I lined them up anyway, we're going to have this backwards L-shaped section here, and that's what we're trying to find. And notice what we want to find is square centimeters. Now that is a wondrous clue to help us figure out how to actually calculate how big this exposed red paper is. Because when we're talking about square centimeters, we're talking about area. So if we were to take the area of the red piece, which we know to be length times width, and our length and width are 8 and 4, 8 times 4. So area of red is what? Ah, yes, 32, and we are now talking about area squarea, so we are talking about square centimeters. Ah, now you see where this is going, huh? All right. And then if we do the same for blue, I just wrote the formula for area, so I don't need to write it again here. So we'll say it is 7 by 3, 7 times 3. So the area of the blue paper is what? Well, 7 times 3 is 21. And again, we are talking about area, square area, so we're talking about square centimeters. Okay. Now we have something to work with here. So red is 32 square centimeters, and blue on top is 21. And what we're trying to find is the difference between them. And so you see this little doodly-doo I did here is something akin to the tape diagrams we did back in addition and subtraction, right? It's a diagram that shows and demonstrates exactly what operation and how to find it. So if we were to take the red area, the 32, and I'm actually going to write all this out so we are clear, and subtract blue's area, we will find the difference between them. In other words, the part of red which is not covered by blue. 32 minus 21 is 8,653.5. No, okay, all right. It's what? All right, it's 11. Okay. Stop messing with me. Okay, fine. Square centimeters. And now let's give a little statement. We didn't have to do a statement, by the way, in that first one because it said, what is the perimeter? And we had P equals. That's our statement. P equals, there's your perimeter. But now we have more of a question. So we can say 11 square centimeters of red paper will be visible on top. That's important, right? On top. If you flip it over, you can see just red. Now you can't see blue at all. It's hiding. Okay, so 11 square centimeters of red paper will be visible on top. And again, let's pause. Does that make sense? Yeah, if you got something that was larger than red's area, like red's total area, and you got, say, 43 or 53 as your answer, you'd say, wait, how could more be showing than there is in all? So this definitely makes sense. We're cruising on here. On to number 3. And in number 3, we have Bryn. And she has a kitchen and a pantry. And so I just want to specify in case you don't have a pantry, because I don't think everybody in the world has a pantry. A pantry is basically a closet right off the kitchen where you can store food and whatnot. Gets nice and messy, I'm sure, right? So you have your kitchen. A pantry is basically a closet, and so it's going to be much smaller than the kitchen. That's something some background knowledge you need to have here. So Bryn's rectangular kitchen has an area of 81 square feet. The kitchen is 9 times as many square feet as Bryn's pantry. Okay, that makes sense. Pantry is going to be the smaller thing, right? That's the closet. If the rectangular pantry is 3 feet wide, what is the length of the pantry? Ooh, this is interesting. Okay, so let's start by just kind of like sketching out the kitchen, right? It's rectangular, we know, and so I'm just going to draw a rectangle. You could tell I don't much care about the dimensions, the length and the width, because we're being asked about the dimensions, the length and width of the pantry. But I do know here, I'm just going to put K for kitchen up top, keep things straight, that this is 81 square feet. And now the pantry, the closet, we do know something about it. We knew 2 things about it, right? First of all, we do know that's 3 feet wide. So I'm just going to make it 3 feet wide there. And the length is what we're trying to find. And I don't really know how to draw that, right? Is it more or less than 3? So I'm just going to draw a line because I really don't know what it looks like. All right. I do know it's rectangular though. All right, so I can do it that way. And now, so the width here is 3 feet. I know that, but I also know something else. It tells me that 81 square feet is 9 times the square feet of the pantry. Okay, so let's think about that. So that means that I'm going to use kind of an equation here. Think about the pantry's area is the kitchen divided by 9. Does that make sense? Because the kitchen's 9 times larger. Or I could say, this would be the same thing. I could say up here, I could say that the kitchen is the pantry times 9. And so if I go ahead and then say, well, I do know what the kitchen is. I'm trying. The kitchen is what? 81 square feet. So if I divide that by 9, I'll get. I wrote 18. 81. Look at that. Even I make mistakes. I'm just going to cross it out. That's the best thing to do. 81 divided by 9. Mistakes are good. It's called learning. Okay, so pantry's area is 81 divided by 9. So the pantry's area then is what? Yeah, you know your facts. 9 times 9 is 81. So the pantry's area is 9. And I'm just going to note here square feet so I remember what I'm talking about here. In fact, I'll even just put a 9 inside there. I don't have room to write square feet, but just remember what that is. By the way, if I did it the other way here, with this, I would have said that 81, the kitchen, going from this kitchen equals pantry times 9, that 81 is the pantry times 9. And I could have just asked myself, well, what times 9 is 81? And I still would have found 9. Now we discover something rather interesting. So if we're going to say here then that area of we're looking at the pantry here, that area is length times width. We now know the area of the pantry is 9. And we know the width. So we're trying to find the length times the width is 3. So what times 3 is 9? Yes, so our length is 3 as well. So now it does say it's a rectangular pantry. So there's a little bit of a trickum in there because when you write this down, what do you notice? Yeah, the pantry is actually a square. However, all squares also fit the definitions of the rectangle. See, so a rectangle, yeah, it's square. Okay, so the difference is 4 equal sides, right? Whereas a rectangle, you have opposite sides equal. So a square, you could technically say, is a type of rectangle. All right, there you go. So anyway, so now we know the length of the pantry is what? 3 feet. And that is our statement here. The length of the pantry is 3 feet. Boom! There we go. Now let's go on to the last one, number 4. Doing right, yeah. And in our ultimate example here, number 4, we have another little puzzle to figure out. I like this one. So let's read it. The length of Marshall's rectangular poster is 2 times its width. Okay. If the perimeter is 24 inches, what is the area of the poster? Ooh, yes. Okay, so we have a width, right? But we don't know what it is. So let's just call it W for now. All right, and then we have a length, which we know is 2 times the width. I'm trying to draw about 2 times long. So, and I can write here that the length is 2 times the width. Or if I just want to be all algebraic about it, I could just label this side as 2W, okay, which means twice the width. And now I know one other thing. I know that the perimeter equals 24 inches. So now it's asking us, what is the area? Well, gosh, we know that area. Let's just take a little note here. We know that area is the length times the width, so we don't know the length or the width or the area. How on earth can we do this? Maybe we can't do it. Maybe they're messing with our heads, man. Okay, well, let's take a step back before we get all paranoid about it. Let's think that the perimeter we know is going to be 2 times the length plus the width, right? And we don't know either the length or the width, but look what we do know. We do know that the length and the width, if we put them together, we have 2 widths here and 1 width there. So length plus width is going to be 3 times the width, right? Okay. So what numbers work here? One way to attack this kind of question is just to try some things. A little trial and error. Okay, so we know, as I'm saying, that the length plus the width is actually 3 times the width. Okay, and I'm going to write that as 3W, meaning 3 times the width. Right? Because look, there's 1 width, 2 widths, 3 widths. So the length plus the width is 3 widths. So what would work in here? And make sense, I mean, because this is, a poster. So we know that the answer is going to be 24, right? We know our value for the perimeter is 24 is 2 times, well, triple the width. What number works here? What number, if you multiply it by 3, and then take that and double it, you'll get 24. Well, we can kind of work backwards here. See, this is a logic problem more than a math problem in a sense, or it's a true math problem in that it's also a logic problem. So if we were to work backwards, we know we're going to be doubling 3 times the width, right? So if we work it backwards, we're going to take half of the perimeter. See how that works? Because that's what we'll get when we do this operation. So that would be like saying, well, then I know, I'm going to put this in a bracket over here because it's just something I'm thinking about. That would tell me that half of the perimeter is equal to 3 times the width. There's only one number that could work there, isn't there? 3 times what is 12? 4. So that would suggest that the width is 4, but let's not jump all over those conclusions there. If this would mean then that the width is 4, well then let's try that out. So 24 is 2 times 3 times 4, which would be 2 times 12, right? So 24 equals 2 times 12. 24 equals 24. It checks out. And see if this makes sense up here. So if this is 4 inches, the width, then what's the length? Well, let's double it, right? 2 times the width. So this would be 8 inches. Is our perimeter then 24? Well, let's do it the kind of slow way. 8 and 8 are 16. 4 and 4 are 8. 16 and 8 are 24. So it checks out. Now, if what I just did, you're saying, kaboo blah blah blah, that makes no sense to me. Well, that's okay, because what you could have done is just tried out some numbers. You could have tried, well, I don't know, 1, 2, then 3, then 4, because you know we're dealing all with whole numbers, right? And that your perimeter is 24, so that places a limit on how many numbers you have to try, how large the width could be. And you know that the length is double it, so that places an even greater restriction on the set of numbers that could work. So you could just try out some numbers. So if you're ever taking a test and you have a question like this and you're like, oh, I don't know what to do, just try something. That's all. Now, are we done? No way, man, because our question is, what is the area of the poster? That's why I wrote this up here, so we would not forget. Our area is the length times the width, which we now know the length is 8 inches. Now it's easy, right? And the width is 4 inches. So our area is 32. Yeah, 8 times 4 is 32. And we're talking about area, square area, so we're talking about square inches. And yeah, That all makes sense and checks out. I don't need a statement that says the area of the poster is 32 square inches here, because there it is. Area equals 32 square inches. It's right there. If you want to write that, go ahead. Well, hey, look at that. That was kind of a fun one. I love those puzzles like that. So here we are. We're at the end of homework time. What are you going to do with yourself? I don't know. But homework time is over, so I will see you next time. It is, once again, homework time.